Hi guys, today's lesson is on 2.3, the velocity formula. And another thing that we can say for velocity is uniform motion. So first off with the definition here, we have uniform motion being an equal displacement in an equal time. So that means you cover the same amount of distance per second. So you might see something like 5 meters per second. That's what we think about when we think about uniform motion. That's kind of the physicsy term, but the easier to understand term would be constant speed or velocity. So lots of you are starting to learn how to drive, and this will make perfect sense to you. Constant speed is like in the car when you put it on cruise control. Okay, so that's an example of uniform motion. If we think non-uniform motion now, that's when you're not going the same speed every second. So that means your speed would be changing. That's like in the car when we speed up or slow down, and we call that acceleration. Now I'm skipping over the graphs once again, but those of you going into Physics 20 will want to take a look at this so that you have seen a graph before you get to Physics 20. We do a lot of work with analyzing graphs. So we're going to start on this slide with the actual calculations. It's important that you have the formula sheet out in front of you. What I noticed in the chemistry unit is that some people were maybe being a little bit lazy and not using the Science 10 data booklet. Now, I emailed it out multiple times and it was posted on my website. There's no excuse not to use it. You also can find the Science 10 data booklet simply by Googling Alberta Science 10 data booklet. So you need to be using the resources that I'm telling you to use. I have on my website the Physics 10 formula sheet. It looks like this. If you have a printer at home, it's probably easiest to print it. If you don't, you might want to copy it down or save it to your phone so that you can bring it up for every single lesson, because we will constantly be using this formula sheet and none others. So make sure you have access to this specific formula sheet. Now, the first thing with physics is showing your work is absolutely critical. When you take physics, we show our work a little bit different than in math. We want to list everything that the question gives us. We want to pick a formula, and then we sub our numbers in, and we actually sub numbers and units in physics. And then we can solve for whatever we're looking for. So in this question, we have an animal that walks 100 meters in 50 seconds. What is its average speed? First thing I do when I get to a question like this, I look at the numbers I'm given. 100 meters, that's 3 significant digits. 50.0, 3 sig digs. I'm going to circle the smallest number. They're both 3, so 3. And that tells me exactly how many sig digs I write my final answer to. Now, the animal walks 100 meters. When you see the units meters, you should automatically know what kind of measurement that is in physics. In physics, if we're going a certain number of meters, that's a distance. If it had a direction to it, I would call it displacement. Seconds, we should all know that. That's time. So in the first part of my answer, and keep in mind these boxes are never given to you on a worksheet or in the textbook, but this is just a guide in your notes for how I want your work to look. Okay, I'm going to start by saying the question gave me distance equal to 100 meters, time equal to 50.0 seconds. And if you watched my video last week about sig digs, you know that the 0.0 is very important. That tells us how specific our measuring tool is. So whatever they were using to measure time was accurate to the nearest tenth. So don't get lazy and put 50. The number in physics is 50.0, so you write it as such. The other thing I can put in my variables is what they're asking me for. They're asking me for speed, which you should know in physics is v. Remember, velocity with a direction is v with the little velocity arrow on top. Now, d, v, and t. The next step in any physics class is to go to your formula sheet and locate a formula with those three things in it. I see this formula right here where my cursor kind of is. This one has V, D, and T in it. So I'm literally just going to copy it down. Okay, that's exactly what the formula sheet said. Now, you might be wondering what those little triangles mean. Those little triangles, let's make a note at the bottom here. That's the Greek letter delta. Okay, from the Greek alphabet. And what this means in science is a change in. Okay, that's exactly the definition here. So if we look at this formula, what it's literally saying is that velocity is equal to a change in displacement or distance over a change in time. The reason why we think about it this way is because I could have a question where maybe my speed is changing from 10, or pardon me, my distance changes from 10 to 20, right? In that case, we wouldn't be going 20 meters. We only would have gone 10 meters. Okay, so it's just a little bit different, and we'll get to questions in the next lesson that take into account that. But really what you might have seen in Science 9 is V equals D over T. For this question, it's the same thing. So here we go. The next step is to substitute the numbers that I know. On the top, my distance is 100 meters. Numbers are always written with proper sig digs and units. And my time on the bottom, 50.0 seconds. We go ahead and solve. What's 100 divided by 50? It's 2. But this is physics, and everything needs to be written with the proper number of sig digs. Remember at the top, we went through and we said 3 sig digs is what our final answer has to be. So how would you write the number 2 with 3 sig digs? That's the number 2 with 3 sig digs. You just add the 0.00 to show how specific your number is. Now, the reason why we sub units in physics, is because you don't have to guess what the units are for speed. Even though you should know that, they're sitting right here, meters per seconds. That's exactly what the units are, and you don't have to guess at that. You just look in your formula. Now, at the bottom here, we have think like a mathematician and think like a physicist. In math, we've already done these questions. We looked at graphs in math, we looked at slopes of lines, and what we actually were finding in math, even though you weren't explicitly told, is we were finding the rate of change or the average speed. So when we calculated the rise over run, we actually found the speed. So these things are connected. You can think about these things mathematically or like a physicist, in which case you're just using different terminology to describe what you found. Let's do another example. As I read it, write the number of sig digs that you see above each number. Bob drove from Edmonton to Calgary, a distance of 320 kilometers. If he drives at a constant speed of 80 kilometers per hour, how long will it take him? Now, this question isn't necessarily in our base units that we like to use in physics, but I'm not going to change it to meters because the units match. Over here I have kilometers per hour. And over here I have kilometers. If they match up, we don't have to change anything. If I had one of them in kilometers per hour and one of them in meters, those don't match and I would have to change one. Now, when you wrote your sig digs, you should have gotten 2 sig digs for 80, 3 sig digs for 320, and circled 2 because it's the smaller number. Now you can try pausing the video and listing the variables next. They've told us right in the question, distance is 320 kilometers, always include units. Speed is 80 kilometers per hour. And how long is asking what would the time be? That's our question mark. You see these 3 variables and you write down the same equation that we just used. Whether you put that little triangle or not doesn't matter. And now here's our substitution step. I do know V, so on the left side of the equal sign, I'm going to write speed. My distance goes on the top of the fraction, and my unknown time goes on the bottom. You just leave it as a variable. Now, I'm going to write these units a little bit differently. You can write them vertically like that, or you can do the fraction horizontally. I'm going to do it horizontally just to show the algebra a bit better. Now, we learned this algebra already in trigonometry in our math unit. When you have a variable on the bottom and a number over here, the algebra is that these switch places. So time comes over here. The number in the top stays, and the number on the bottom is going to be the 80 kilometers per hour. So here we go. In your calculator, you can go and divide those 2 numbers, and you should get 4. If you just write 4 as your final answer, you're going to lose a few marks because first of all, you don't have the proper sig digs, and second of all, you don't have units. We need to know, is it 4 seconds, 4 hours, 4 alligators? What is the 4 representing? The other thing we need to know is the units. Now, the kilometers cancel, and when you have hours in the bottom of a double fraction like this, it becomes your units over here. How many sig digs did the question want? I circled 2, so I'm going to write it as 4.0 to make 2 significant digits, hours. Shelley walked at a constant speed of 2.00 meters per second for 3.00 minutes. If she walked in a straight line, how far did she travel? First step, 3 sig digs, 3 sig digs. Our final answer will be written to 3 sig digs. Second thing I notice when I read this question is there's a unit problem. These units of time do not match. 3 minutes and 2 meters per second. They both need to be in seconds. So this is where we need to know some common conversions. How many, if I have 3 minutes, how many seconds are in 1 minute? 60. We all know that. I times by 60 seconds, so the minutes cancel on top and bottom, and this is going to give me 180 seconds. Now, I'm going to write it with the same number of sigdigs so I don't get confused. 3 minutes was 3 sigdigs, and 180 seconds is also 3 sigdigs. So I'm ready to write my variables. Speed was told to you in the question. It might be helpful for some students who are struggling to find what these numbers represent to highlight the words in there. Speed, and then of course minutes is measuring time. So the speed is 2.00 meters per second. Time, we discovered, is 180 seconds. The units have to match. And we're looking how far did they go? That's a distance. The formula we're working with for all of these questions is V equals D over T. Now I can sub my numbers in. Here's my speed. D I don't know. And T is 180 seconds. Now, what would the algebraic step be here to get D by itself? Well, if we wanted to get rid of the 180 and it was being divided, we'd have to do the opposite. The opposite of divide is times. I'm going to times both sides by 180. Top and bottom cancels, and on this side we have just D left. And on the other side, we have what we need to punch into our calculator, 180 times 2. Now, 3 sigdigs, the number is 360. Now, seconds have canceled. We're left with meters for our units. And we should know that. What is a distance measured in? Meters. Now, this is perfect to do it this way. Plug your numbers in and do algebra that you've been doing since junior high. I'm going to show now a method for those students who enrolled in Physics 20. What we want you to be able to do in Physics 20 is we want you to be able to do algebra with no numbers. So we don't want to sub things in. We want to rearrange the formula without doing that. For instance, if I wanted to rearrange this formula like we did in this question and get distance by itself, I would multiply both sides by time. I can cancel time just like I can cancel numbers, and I would get D equals time times speed. Let's try it again over here. What if I wanted to get time by itself? Well, even though there's no numbers in here, I can still do the same algebraic step we did earlier of switching T and V, and I could isolate for time. These are the two things that you're going to be doing to change the formula around for this. It gets a lot more complicated with more formulas that maybe have things adding and subtracting and multiplying and dividing. There can be more steps, but this is a skill that we practice in Physics 20. Now, let me mention this thing. Lots of students want to use this triangle to organize their formula. The reason why I don't recommend using this triangle is because it really only works for this formula. Everything else that we use gets more complicated, and there's no simple memorization technique of this triangle to memorize the formulas. Memorizing the formulas kind of gets you out of doing the algebra, which is really the skill that we want to practice here. So make sure that you're not writing this triangle down and kind of taking the easy way out. I want you to be doing the algebra every single time. If you need to rearrange the formula for T, then take the steps that we took in the previous example to do that. If you need to rearrange it for D, take the steps in this example to do that. Rewatch the video multiple times until you really understand what you're doing. Try not to find little things that you can memorize to get out of doing the work. Try and understand the actual algebra behind it. And one more time, make sure that you have a copy of the formula sheet at your disposal, whether you print it copy it out by hand, or save it on your phone, you need to be using this formula sheet that is linked on my website. You can find also on my website the practice questions that go along with this section, as well as the answer key, and I'm always here to help you. Just let me know if you have questions.